some of the live reloading capabilities in my game engine pmtech. Live reloading of C++ code, shader code and render configs make for very rapid development and prototyping. It's a really useful tool to help make small demos, graphics demos, or develop game ideas. So what I've got here on the right side of the screen, I've got the pmtech editor, which is running pmtech engine inside an application, and on the left side of the screen I've got some C code, or C++ code, which I can compile into a dynamic library, and I can reload this in real time while the editor is still running. In the editor I can select objects and I can enumerate them in this UI. I can see that I've got a box, a ground, a light, I've got a grid. I can use the editor to do stuff, but it's more interesting to me as a programmer to be able to use reloaded C++ code because I can develop ideas much more quickly. So to demonstrate this, every time I recompile the C++ dynamic library, it will call this function onload. If I just simply clear the scene and return, then rebuild, then the box and the ground has now gone. So I have this small struct which has an onload function, an init function which has to set up some function pointers just because of how I've implemented the function calls at the moment, and then it gets an update function with a delta time. So within pmtech I have a debug rendering UI, linear algebra UI, library, and I can use that to develop algorithms or gameplay mechanic ideas. I can give you a demonstration of this by writing some code live and seeing it reflected in the editor. So if I make something like a vector, let's say it goes up in the y-axis, I can add a line, so it starts at 0 and it goes to A. Let's colour it in magenta for classic debug colour. Oh, it needs to be a vec4 magenta. So I've got a small line drawn, and I just compiled the code. I didn't have to restart the editor. So if I do this again, the camera, I can position it where I want, and I could add another line. I'm going to normalize this because I want it going add another line, B, and I'll colour this one in cyan. So now it's drawn the cyan line, and then I could do things like, if I want to take some arithmetic, I could do, say, cross product between A and B to give me C, and I can add and I make C yellow, vec4f. And the cross product gives you the orthogonal vector to cyan and magenta. There's a lot more I can do with the debug rendering API. It's an immediate mode style, so I have to keep every update you call add line. These lines get pushed into a larger buffer and the draw gets made later. So it's immediate mode style. It's not actually doing the draw call when I call add line, it's just adding lines into a buffer. But it has, in addition to adding lines, there's also a whole host of debug primitive functions that can be used. So I could add something a bit more interesting, like an AABB. Let's say this starts at something like 0.5. So an AABB can be defined by the minimum maximum extents. So I'm going to start the AABB at 0.5, 0.5 and add a bit onto that. Let's make it 1 unit, make it 2 units large maybe, and then I can do add AABB, and that will take the AABB min, AABB max, and I think just a colour. Hopefully I'll make this one in white, and there we go, we've got an AABB there. I'm just going to change the position of it slightly. Let's see if this works. Okay, cool. And then also I have this linear algebra library with a whole load of geometric and intersection tests which I could use to find the intersection point between the cyan line and the AABB. So the function works by it fills out an intersection point. It's called ray versus AABB. It takes the AABB min, AABB max, the ray start, which is 0, and the ray vector, which is the normalized vector of B, which is already normalized, so we don't need to do that. The vector of B is cyan, and then it will return me IP, which is the intersection point. And then I can add a point with the Debug rendering API to say, add me a point. I'm going to say it's going to be 0.2 in size, and let's make it green to indicate that it's the intersection point. And there we go. The green little cross has been added to show that's the intersection point. And then if I was to move the AABB a little bit, we could also see that the intersection point is in the correct place, which is pretty nice. So this is the update function. As you can see, it would be great for prototyping physics, game mechanics and stuff where you have to do a bit of linear algebra. You might want to debug points and lines and vectors. So I'm going to get rid of this stuff now. That was just a quick demonstration of the update function. But where really this live reloading comes into even more powerful usage is manipulating the entity component system. So every frame I have an entity component system which is structure of arrays, data oriented. It has a core update which every frame will take entities, it will bake their world matrices, it will make draw calls. So in the onload function I can simply choose to add some primitives or some entities. So in here I'm adding a directional light, a ground, and a box. And these get added in the load function. It's not immediate mode style, so once I add something in the scene, it's going to be persistent. So if I add these things, recompile, I've got here a cube, and I've got a ground, and it's just added those in there. And then in the update function, I could start to apply some like logic which can manipulate the positions of the objects that already exist. So I already had a mess around with doing a few things in this tool set, but I'm going to try and make a small interactive or looping animation that I can use as a demo. The first thing I'm going to do is I want to have some lights in the scene. I can also, because everything's hooked into the core engine, I can add things like a shadow map just by adding a flag on this light. So shadow map flag adds a shadow, and then if I add another light to the scene, I can add a shadow to that. So the way that works is that all the shadows are stored in texture arrays, so you can have as many shadows as you want, obviously at the cost of performance. So I do want to have another shadow map, and I want to have its direction to be slightly different to the existing light, just because I like the interplay of having different shadows. You get quite nice different colours and things. So I think I'm going to add about 4 lights, or maybe I'll see how it goes. I'll add a couple more, and then I'll choose some colours for them. So to add entities in the entity component system, they're stored in the container, which is called scene, and inside the scene container you can access all of the components. And these blocks of code are kind of the way that you just set up an entity, and once it's been set up, it's got a lot of core functionality which is being automated. So if I go for the third light, maybe I can make this negative. Okay, so got a bunch of shadows there. I'm going to choose some colours for the lights. So at the moment they're just white. I'm going to go for some nice, this is something like a nice kind of orange colour maybe. Quite nice. So go for like a kind of more bluish kind of one, almost like the inverse of what I just did. Pretty nice. So this one could be a slightly magenta maybe. Finally, maybe like a kind of a greenish one. So now the grid's Z fighting a bit, so I can disable that from inside the editor. I can use the editor to do lots of this stuff as well, but it's nice to be able to edit code as well to do it. So I've got a bunch of lights in there and shadows. I'm not sure if I like the colours of those just yet. I actually think potentially the last light actually killed it a little bit. No, I think it was maybe better when this one was actually more grey. Okay, so I want to make a small animation of some like moving cubes. I don't think I need the ground plane. I just kept the ground plane there so I could see where I was casting the shadows. So I'm just going to go back to a box. I can't see the shadows now, so that's why I did that. And yeah, this basically is all been set up from the onload function. Every time I compile the code, it calls the onload function, and then once the onload function has been called, we just get an on update called each frame, which has a delta time. So I need to actually get a reference to the cube object. So I'm just gonna start an anonymous namespace here with some junk that I can put into it. So cube, I actually called it box there, but it's fine. Cube equals box. So that's just so I know the index of the entity. And then, oh, cube is ambiguous. I want to add more cubes to this eventually, so I'm going to call it cube start. And then it's seen transforms cube start. I could say I can modify its translation by adding sine wave. I think I'm going to need some kind of static float here to track so P will be incremented by delta time every frame, and then P gets passed into sin. That's not really doing anything. So what needs to happen is I actually need to set this flag after I've modified a transform, because if something has a transform and it's not changed, it doesn't need to recalculate the world matrix for it. So it's not transform, it's entities. So this is entity flags. I need to tell it that I've modified a transform, and then what I've got there is it's going pretty big. I'm going to put the grid back on actually for the time being. It starts at 0 and it goes up and down. Okay, that's kind of cool. It's going up a bit too high, so I'm just going to make the peak of that a little bit shorter. I think that should be reasonable. Okay, so this is the update function called every frame. There's a whole host of other update happening elsewhere, which is generating, it's recalculating the position of bounding boxes, calculating world AABBs, and making draw calls and all sorts of stuff. But we can leverage that by using the hot reloading in pmtech and just write our own little bits of logic that we want to modify. So what I want to do in here is actually have a load of these boxes and like a grid or an array pattern, and maybe assign them some different colors and give them a different sine wave offset to make like a wavy effect. So instead of adding a single box, what I'm going to do is I'm going to take an array, or a loop, sorry. I'm going to make a loop, and what I'm going to do, I'm going to say size, side size. So let's say we take 10 cubes, 10 by 10 grid of cubes. Side size plus j. Okay. So now I'm going to create 10 by 10 cubes, so 100, and I'm going to have to position them slightly differently. So let's start with figuring out how to do that. So pause, for simplicity I'm going to just start it at 0 for now and then figure it out in a little bit. I'm going to need a cube size. I don't know how big these are already. I think this might be 10. And then I probably want some kind of padding, just so they're not right next to each other. And so I'll go for 1. So I'm going to set my scale to cube scale, translation starting at 10. I think so it sits, that's cube size. The box primitive comes as from a geometry resource. It's pre-created. The cube extents go from -1 to 1, so when multiplied by scale, the cube size of 10 is actually 20 units wide. So it needs to set the translation. Actually, let's forget about that. I'm just going to set the translation to pos, and for each pos I'm going to plus equals the cube size and see how that comes out. The first box needs to be the cube start box. So if I is 0 and j equals to 0, then cube start equals box. That's just so I know the starting cube, and then these values might need to be made accessible to the onUpdate function. So now if I run this, I should add, right, I've added a load. They've gone like this because I'm not resetting the position offset. It's really annoying that when I select this window it hides Xcode even though it should remain. Okay, so that one's moving up down and they've been positioned like that. So pos, when we start here, pos x needs to be reset to 0, and cube size, pos y needs to always be set to 0. So there's actually a vec3, the step value I want, which is going to be cube size, 0 stepping in the y-axis because I want them to just be flat. And so if increment step, oh, that's still not quite how I expected it to be. Okay, so I know what it is. I want to increment the x step is going to be cube size, and it's just a float. So I only want to increment the position x in the j loop, and I want to increment the position z in the I loop. There we go. So we've got a grid now, but the cubes are actually overlapping. So this is what I was talking about before. The step is actually cube size times 2 because the cube size, it's not a unit cube, it's the cube is 2 units. So now we can see this guy, he's slotting in perfectly, but also we did say we wanted the padding. I think the cube padding would be, don't know if it will work best like this. Okay, that seems about right. Okay, agreed. But now my start position is not very good. I don't want to start at 0, I actually want to start offset from 0. So position is going to start at step times side size. So now it's gone too far, so it's side size is times 0.5. So I just want to go half the size. There we go. That's kind of correct in the x-axis, but the z-axis isn't correct. I believe it looks like it's still at 0. Position X needs to start at right, so start is going to be this minus step times size times 0.5. We start the pos as start and start. Oops. So the hot reloading handles all stuff like fail compilation and things like that, so it's quite handy. This is missing a semicolon. Build succeeded. It's failed. Something's gone wrong. So it can be a little bit flaky. There's times where the live reloading might just start to not work. So if I just go back now, something can cause it to get stuck in a situation where live reloading fails, but there we go, we're kind of back now and it's running again. So like I wanted, here's a grid of cubes I wanted to make the demo out of, so I can get rid of this now. In addition to live reloading C++ code, I can also reload shaders and render pipelines, which I have in these other text editors. These have already been implemented for a while now. So I want to assign some different colors to the cubes. So while I'm doing that, I'm just going to output the color RGB to be the albedo RGB, so it's going to be unlit. So now you can see they've just gone purely white. They've got no shadows or lighting on them. That's just so I can see the colors better. I'm going to use HSV to assign a different hue to the different colors. I think HSV is a bit nicer than RGB for color gradients. So I can make a vec3 HSV value, and this might be different per that's annoying, for each cube. Let's see what we got. So we want to set a different hue and then a uniform saturation and variance. So maybe go with 1 on the saturation, and then the hue I'm going to just do, I'm just going to pass in I, and then to assign the color I need to actually cast the material to the correct type. So each entity has a material data, and this is a pointer to data of generic floats. The reason I can figure out what it is I have a header which is output from the shader compilation, and this can tell me, I can cast to this struct and it will show me which values I'm using. So I'm using forward lit, which is the basic forward lit shader. It applies N shadows, N lights. It can do directional lights, point lights, spotlights, sign distance field shadows, all sorts of stuff. It's quite a heavyweight shader that can apply everything. If you were to make a game or something, I would definitely optimize away things I don't need, but performance on a desktop or even MacBook is pretty good to just apply all of the techniques. So the way this works, I take a pointer to what am I doing? Yeah, I did need that actually. I need a pointer to a forward render, forward lit structure, and then once I've got that, I can look at this and I can set the albedo, and the albedo wants to be HSV, the HSV value, but it needs to be in RGB. So in my maths API, I've got maths HSV to RGB, and you pass in that HSV value. So now if I save this, oh, it's failed. I think it needs an alpha. So this might be when it broke before the failed compilation. No, it's all come out as red, which isn't great. Oh yeah, okay, so what I want is an I, and I want to divide it by something, side size, so we distribute the gradient. And there we go, there's a color gradient, a little bit extreme maybe, it's every color. Let's see, we do I plus J, so that gives us a bit of a zigzag. Let's see if I can make it a smaller range. I don't know what this is doing now. Analyzing. I think I've done something like static analysis by mistake with the shortcut I pressed. Well, this is annoying. Stop that build. Right, okay, that's fine. Come on. Right. Okay, that's looking a bit nicer. Maybe if I just tone down the saturation slightly. Let's see what this does. Okay, I'm going to see what this looks like now by recompiling the shader with the lighting on. So I can just remove this bit of hard-coded code. There we go. Okay, that looks quite nice. Bit of a gradient. So now I just want to apply a different, I want to apply a sine wave to the different cubes. As well. So I just need a loop. So this starts at cube start, and then current will increment each time. We need size to be accessible. This is inside a class actually, but I chose to put them inside anonymous namespace because I am used to doing sort of more C style APIs. So let's see, cube start, side size. Okay, so it's going to apply this P to everything now, if I recompile it. Right, we're all moving up and down. Just going to change the colours slightly again. Okay, we get a bit more yellow and green. It's a bit nicer with the more subtle gradient. So everything's moving up and down uniformly. What I really need to do is to add an offset, and if I do that with I, then we get this. Oop, okay, that's kind of cool. And that can make it go diagonally. See if this should be able to slow it down. I'm just going to turn off the debug grid. I feel like I'm going to need a few more cubes because I want this to be full screen so I can do a capture of it to make the looping animation. I don't want to see any oh, hold on, side size. Did I initialize it there? Cube size, side size. Okay, there we go. We've got side size now, but it's not centered. Ah, damn. Okay. Right, much better. Okay, so this is kind of a cool effect that I've just managed to build up fairly quickly. Obviously you can see how it could be, you know, spend more time doing things differently. With this one, I'm not so sure about the colours, but that's just how it came out. I should also maybe demonstrate that in addition to reloading shader code and C code, I also have these render configs which can configure the render pipeline. So this one is called editor renderer, so this is the one that's being run at the moment. You can set up different views, so there's a view for rendering the main scene, there's a view for rendering the debug lines, there's views for picking and other stuff. But I can configure them from in this JSON style syntax. It's called JSN. It's actually a bit more lenient and user-friendly than JSON with some more features. But I can change the clear color. I can also change the raster state to wireframe. So if I recompile this. It takes a little while, but it's changed the clear color of the screen to cyan, and it's changed the raster mode to wireframe. And so if I just put this back, looks a bit nicer. Back to black. And so in the render config, you can also supply all sorts of stuff: depth, stencil state, shaders. You can have a per pass shader. You can use the materials in the entity component system. So it's really quite powerful. I think that's, you know, kind of a decent rundown and a little live demo of the live reloading capabilities. If anyone wants to use it and has some cool stuff, then I'd be interested to see what you can make. Cheers.